going to conferences all the time is the main driver for progress in your skill set and also your relationship, and basically any professional can become a better professional by attending conferences.
It's not the standard, okay? It's a movie theater, but the visual is great and the sound is great, and I've seen a lot of room and space, and I think it's organized well.
Seeing all the people here today and they're excited about stuff, you can see the energy and the desire to learn and do new things.
And I was positively surprised about the depth, the technical depth of the sessions, and how that makes the tester part of the team.
I think developers do benefit from coming to QA conferences, just the same as testers can benefit from going to dev conferences. You've got to have a broad understanding of what's going on.
It's really inclusive. I would say it's super diverse. People are really, really open and friendly, and it's really organized.
Conferences are well worthwhile just for the ideas that they spark in people. When people come back to the office, they're full of ideas and they're all energized up.
Hi, I'm Troy Walsh from the US. I am the Quality Engineering Practice Lead for Magenic Technologies in Minneapolis, Minnesota. I'm here today to talk to you about testing with .NET and how with the use of .NET Core you can test everywhere. Hello TestCon, and welcome to Testing Everything with .NET Core. My name is Troy Walsh. I am the practice lead for the Quality Engineering Group at Magenic Technologies in the US. I've been a .NET developer for nearly 15 years now, and with a specific focus on testing. So let's jump into it. So let's start off with an overview of what we'll be covering. First, we're going to go over kind of what .NET is, how it works. We'll talk a little bit about the related languages. Then we'll transition into .NET Core and kind of how that relates to kind of the older version of .NET. And we'll talk a little bit about the future. Then we'll go into the IDE options. We'll focus on two main IDEs, that being Visual Studio and VS Code. That being said, there are other options, but those are the ones we're going to focus on because they're the ones that get used the most often. Then we'll touch on some of the testing capabilities for .NET Core, and then we'll go into a demo so you can see kind of how this would run in more practical terms. So we'll be running that on the Linux subsystem. So the same way that we're running that, you can use to run on Mac, and you can actually do the same thing on Windows, right? It's completely cross-platform. And then we'll open it up for some questions. So let's start off with what .NET is. So .NET, it's a royalty-free software framework. So it's a framework for writing software. And like it says, royalty-free. So you can write code and you can own it, which is nice. Development started for it in the late 90s. Pretty late 90s from what I can tell. And the initial release was in 2002. So .NET supports multiple languages, so C#, F#, and VB.NET. And then there are also some older ones that, depending upon what version you have, maybe you can get some backward support. So there's the ability to have C++ and JavaScript.NET. And an interesting older one is J#, which is kind of Microsoft's implementation of the Java standard. It was an interesting project, ended in lawsuits, and yeah, they dropped support for that a long time ago. So the way .NET works is you have your .NET code, so either C#, F#, VB.NET, whatever language you decide. Word of warning here, don't use VB.NET. VB.NET is terrible, and it's really not getting the love. I suspect that one's going to be deprecated sooner than later. So you have your code. Your code gets compiled down to a CIL, or a Common Intermediate Language. So think of this as pseudo-compiled, right? It gets it pretty far down, but not machine level. And the result of this compilation is either EXE or DLL. Now at runtime, the .NET CLR, or Common Language Runtime, will do a just-in-time compilation of this CIL content, and this will change that code into more of native code, right? So you can abstract your code away from what exactly is going on in the system. So unless you're doing something like I don't know, writing drivers or something like that, right? For the most part, you don't care. Right? I want to deal with a string. I don't really care how memory management works on that system. That's a problem that's already been solved. The CLR does that just-in-time compilation, makes it native, and that does execution. And it does kind of a virtual machine kind of thing. So there's a safe space for it to run in. So those of you familiar with Java, this is very similar to the JVM. So this gets us to kind of the primary language. So initially, the language C# started in 2000, and it was released in 2002, the same time as the .NET framework came out. So it is the primary language for .NET, so much so that C# and .NET are kind of used interchangeably. It's actually a little weird if you're doing .NET and you're not doing C#. So yeah, if you hear one or the other, they're pretty much synonyms. It is a variant of C, very, very, very heavily influenced by Java. As a matter of fact, if you jump back and forth between C# and Java, they're close enough that it's annoying. And I do this on multiple projects. So it is fun to see how when one adds a feature, the other adds a feature. So if you are really interested in kind of the legal aspect and the historical aspect of where C# came from, I would strongly suggest looking at some articles about C++ or J++ and J# to get some context. It's really interesting, but a whole different presentation all by itself. And you kind of have to be interested in the legal part. Suffice it to say, yeah, Java people really didn't like Microsoft having their own version and making it just a little bit different. Really nice thing about C# is it comes with a ton of class libraries, and very consistent class libraries. If you have ever developed in, say, C++, there's like standard template library. So there are libraries that, at least in theory, exist and work a consistent way. With the C# implementation, they kind of took that idea and kind of embraced and extended. So a lot of the common things that you do again and again, like how do I talk to a database? How do I write to a console? How do I do this, and this? That's all built into the language. So those libraries are readily available. And using things like NuGet, NuGet.org, you can pull in other libraries really easily. I mean, same way that you do with other languages, say Maven, NPM, whatnot. So, interesting thing happened in 2004. In 2004, some folks on the Linux side are like, do you know what? This C# thing looks like it could actually be okay. So they started creating something called Mono, and it's an open source compiler for C# code. And this would run on Linux systems. And it wasn't too bad. You can actually use Mono now to run some of your Windows applications. It's pretty cool. So .NET, that gets us to .NET Core. So .NET Core, I think it really came to fruition. Like all the underlying pieces kind of came together in 2016. So 2016, Microsoft acquired a company called Xamarin. So they made mobile applications, or they made software for making mobile applications that allowed you to code in one language, C# being one of those languages, and then it would compile for the different mobile types. So I can use like 90% of the same base code for my iOS, Android, and like Windows native app. A really cool idea. But they also kind of owned Mono. So this port of C# that was able to run on Linux, well, Now, Microsoft kind of bought up the company that was maintaining that. At the same time, Microsoft joined the Linux Foundation. So Microsoft at that point kind of went all in on Linux. A little inside baseball, good share of this was because of their cloud offering, right? A lot of what they needed to do from a cloud hosting perspective meant they needed to have Linux. Right? A Windows Server works for some applications, but it's massive overkill for others. And with containerization, yeah, you need to have that Linux support. So that kind of gets us to .NET Core was actually released in 2016. So these things all kind of happened at the same time. .NET Core is a open source implementation of the .NET framework. Note the .NET framework was the original .NET, which was limited to Windows, so it only ran in Windows. So that first implementation, it had, I'd say it had about 60% of the features that .NET Core did. So not everything, but still, I mean, for a new offering on those other systems on Mac, Linux, had a lot of really good functionality. Like I said, it runs on all three of the major OSs. And if you do some reading, there are some hobbyists that have got it running on other systems. But we'll just focus on those big three. And I think this is the real key. It works with all modern container technologies, right? So when you're moving to the cloud, containerization is it's kind of where we are today. And Microsoft kind of saw this, and I think this is why they put so much effort into getting something like .NET Core. And .NET Core it's actually gone really well to the extent that .NET Core is going to become the official standard for .NET. So right now there is a split between .NET Framework and .NET Core. They're coming back to being exactly the same thing for .NET version 5. So .NET Core will be the thing. So now we talked about language framework. Now, if you're developing, you probably need some way to, I don't know, write your code, have something tell you when you forgot that comma, when you forgot that semicolon, you didn't write the language right. And this gets us to Visual Studio. So Visual Studio was originally released in 1997, so it actually predates .NET. Originally, it supported J#, maybe see J# again, C++, and Visual Basic. 2002, where we got the release of C# and J#, and .NET, right? These all were released together in 2002. It actually came with the release of Visual Studio. And Visual Studio is very mature. It's had a release about every other year since 1997. So as you can imagine, it's been going on for a really long time, very polished, very stable. One of the best development IDEs out on the market. That being said, it only works on Windows. So you can do .NET Core development on Visual Studio, but you can't have Visual Studio on non-Windows machines. So that can be a challenge for those of us that want to use .NET to test other places, right? I don't want to have to write my code on one system and then go to another in order to run it. So this is where VSCode comes in. So VSCode, this was released in 2015. Initially, it did not support .NET. I believe it was more Python, Ruby focused. That being said, things have changed in the last 5 years. It works on the big three, and I'm sure other systems. It's very lightweight, and that's one of the problems that a lot of developers have with Visual Studio. It is heavy. Right? It's been around for 20 years. There's tons of stuff stacked on it. Not the most performant thing ever. It's kind of become bloated. So VS Code, much lighter weight, highly configurable, and easy for you to create your own extensions, and a vast extension library. So there are a bunch of pre-built ones from Microsoft, Yeah, Microsoft, Oracle even has one for Java. So you can kind of pick whatever language you want, and there's probably an extension in VS Code for it. And it can do pretty much everything, which is kind of the good and the bad part, right? I can do everything with this, which means I can do everything with this, which means you're probably going to lack some consistency, or I have to know what pieces to pick and choose. That being said, this will run everywhere. So a very good option, especially if you're on Linux or Mac. So this gets us to testing. So we have the code, we have the IDEs, now testing. So early on, testing for .NET was pretty much something called NUnit. So NUnit is a testing framework, which and the N, I believe the N was for .NET. I'm a little iffy on where that naming convention came from. Uh, it's open source. It's an open source unit testing framework specifically for .NET. It's kind of ubiquitous. It can be used everywhere and really good core functionality. And we can use this for both unit testing and for integration functional, right? The context is what matters, right? The context of how we're using it. So in 2005, Microsoft kind of released their, I'd say, competitor to NUnit, which was MS Test. It's closed source. It only worked in Visual Studio. You actually legitimately had to have Visual Studio installed in order for it to work. And yeah, it was kind of heavy. It wasn't the best thing. That being said, it did have really, really good integration with something called TFS, Team Foundation Server. And this is kind of Microsoft's equivalent to, I'd say, Jira with GitLab and Jira with GitLab and Jenkins. You kind of mush those all together, and that's kind of TFS. So in 2016, which you'll see again, 2016, Microsoft created MS Test version 2. And this was actually a huge improvement. I did not like MS Test. I really like MS Test version 2. Really nice thing, it's now open source, so you can use it everywhere. It works with .NET Core and it works with .NET Framework, right? There's a version for both. And they borrowed heavily from NUnit. So the things that people really loved about NUnit, a good share of them got integrated into MS Test version 2. But another really nice thing is it kept that strong integration with TFS, or now the cloud version, Azure DevOps. Which is really great from a testing perspective. This allows me to integrate my regression, integration, whatever test with my build deployment system. And it's not just that this works with TFS and Azure DevOps, but this also works with most modern build systems. So if I'm using Jenkins, Jenkins knows what to do with these result types, and TeamCity knows what to do with these result types. Frankly, in most of these testing tools, they spit out some kind of XML that the build systems know how to interpret. So let's talk about a couple of the features. MS Test version 2, they provide the ability for you to do kind of setup and teardown, and you can do this on multiple levels. So you can do it at the assembly level. So I can say before any test run, do this thing. And same for cleanup. After all my tests are done, do this cleanup. You can also do that on the class level or per test. So that gives you a nice ability to kind of target when do I want to do these before and after steps. You also have the ability to categorize your tests. And this is really important when we talk about kind of larger test suite, where maybe I want this test to run on Linux, or I want this one to run on Mac. Let's say that these tests don't make sense on other systems. You can easily add test categories. You're allowed to add prioritization, properties, like custom properties, and these can all be used for filtering. And you do have the ability to ignore tests. This is bad, don't do this. You probably shouldn't be ignoring tests, but it's nice to have it. And then for those of you that care about your integration with Azure DevOps or TFS, you have the ability to link work items. So this doesn't actually do anything. It's more of a tagging system. So let's say that you are using Jira or something like that. You could use these numbers, these were kind of numbers for that as well. So just some nice categorization. And then they have Assertion libraries built in. You have, if you're using MS Test, you can use their Assertion, or you can use the NUnit Assertion libraries. Actually, you can mix and match them since they're essentially just fancy exceptions. Um, yeah, they can be mixed and matched. And then you have kind of the assertions that you'd expect, right? Assert is true, is false, or equal, not equal, not null. And then you have some special ones where you can say, okay, I expect this piece of code to actually throw an exception. You can also use the inconclusive assertion. Let's say that you get into a state in your test where you're not sure if it passed or if it failed. This is where you can actually set the test to inconclusive. Or you can flat out say, I want this test to fail. I got to this line of code, that means that this test failed. We also have some kind of more powerful features. For instance, we can do data driving, and we have a lot of options here. So we can do it kind of as part of the header, right? We have up here, we have our data rows. So we can have data rows that will data drive. This is typically more useful, at least in my opinion, this is typically more useful when you're talking about unit tests, right? If I'm talking about integration or any of those kind of tests, I probably want to go with more dynamic data. And that's kind of the second example where we basically provide a IEnumerable function that returns results for us. And we could hook this up to, say, a database query or any of that kind of stuff. So, and this by no means covers all of the data driving capabilities. Just know that they're there, and what you're looking for probably exists. And then you can go more with like the file and SQL format directly. I really don't like that, and it doesn't really work with .NET Core, so not a big deal. But you can use CSVs, XML, SQL as your data sources. You can also use TFS as a data source. This sounds much cooler than it is. This is a unholy nightmare. Please, dear goodness, don't do it. But know that it is something that you can do. Okay, and that gets us to parallelization. And this is awesome, right? You want to be able to run your tests very quickly, and this is one of the ways of doing it. So MS Test allows you to set up parallelization. You can do this a couple of different ways. You can do it as part of something called a run settings file. So run settings will set additional values for your test run. Oh, or you can do it on the code level. So I can say, okay, for my code, I want to run tests 4 wide. So nice capability. And then of course, let's say that there are tests that you don't want to run in parallel, or they can't run in parallel for some reason. That's where do not parallelize. So you have a lot of really rich control. So with that, let's jump into the hands-on demo. So let's go into what this looks like in real terms. So for this demo, I'm doing this demo on a Windows machine, and I want to have access to a Linux system so you can see kind of what the code does and how it will run on a different system. So for this purpose, I've installed the WSL, Windows Subsystem for Linux. It's actually the Linux subsystem for Windows. I don't know why they named it what they named it, but they did. So the Windows subsystem for Linux allows us to run basically Linux containers on our system. And then I will actually be running my automation inside of those. I have this blog post where I go through kind of how to set this up. You can either go through this, Google foo it yourself, whatever. There's a couple of key pieces I want to point out here. And this is regardless of what else you're doing. You want to make sure that you're installing the .NET Core SDK. because we're going to be doing development, so you'll want the SDK. And then we're also installing Chrome on our Linux subsystem. And something to note here, the way we have the Linux subsystem set up, there's not actually a UI component, so we'll have to run our browser tests headless. Cool. So let's go over to a copy of, we have VSCode here. You'll note there is no code. I haven't done anything yet. And I'm connected to one of my subsystems. So I have the ability, and this is an add-on where I've chosen which subsystem I want to connect to. So for this one, I'm just doing my regular Ubuntu, and I have all of my stuff installed. So the first thing I'm going to want to do here is I want to install some templates. So I have a jumping off point for my test automation. You can start directly from NUnit or MS Test if you like. I just don't want to take that kind of time in this presentation. So I'm going to install, and this is adding some testing templates for us. In this case, I'm using the Magenic pre-built ones. Let's copy that. And now I just .NET new, and then whatever my template is. And this is going to take the code and it's going to kind of get it all set up for me. So you'll see in this case, I have all my code in here and I have, my test pieces. And the code that we're using here is highly configurable, right? Because I want my code to be configurable. I don't want to be tied to specific systems, but this allows me to say, I want to point to different websites, different systems. And then all I need to do is build. And as soon as I build, now I will have a test that I can execute. I've added another extension here. Actually, let's look at the extensions that we have. I have the .NET Core Test Explorer, and that's this. It just makes it nice and easy so I can go in and have a single view for how I want to run the test. A nice little tool, not necessary, but once again, nice to have. Okay, so I'm going to pull up another version of this, and you'll see here we have a simple NUnit test. This is essentially a unit test, right? And this is something I want to kind of point out from the tooling perspective, whether you're doing a unit test or a regression test or integration test, right? That's context. As long as you're using the same underlying tooling, they can all work within your CI/CD pipeline, like connecting to your build servers, that type of thing. And this is part of why I've chosen to use NUnit or MS Test in this example. And I would caution you, if you're going to make your own test runner, don't. That's a really bad idea. You've just made sure that it doesn't work out of the box with any of the build server types. Okay, so we have our code here. That's kind of boring. Let's look at our Selenium code. So if we go up here, remember we mentioned that you have like class initialize, class setup, and assembly cleanup, assembly teardown. This allows us to do custom setup and teardown before and after our test. So we can set some of the context around what's happening in our test and clean up after ourselves. So in this code, we have some simple browser tests. If I go up here and look at my models, no, I don't want mobile, I want web. You will see I have login page, simple login page, basic page object model. Nothing too out of the ordinary, right? We've all done login tests, so you get to see, okay, here's how I do the test. Then you have models for web services. So in here, you'll see we also have web services. We're doing basic, basic gets, just so you can see how this works. And really cool thing about this code is, right, I have it running on the Linux subsystem, but I can run this on Windows, I can run it on Mac, I can run it on Linux, and at least in theory on a couple of other systems. So let's run these tests. I'll just hit run. And you'll see they've already kicked off, and these should run relatively fast. And while that's going, I will note that with my configuration, I am doing, let's see, where's, yeah, Selenium. My browser is headless Chrome, right? Because I'm running on that Linux subsystem. It doesn't actually have a UI on it, so it has to run headless. If we go back, all of our tests pass. That's good, but what happens when they don't pass? So let's change this to false, and let's just run this one test. And hopefully I don't have to run a new build. Let's do it anyway. Cool. And which one is that? Enter valid. So now this is going to run through that exact same test, and it should fail. Oh, we got a failure. And something to note here. So we have logging set up. I go in here. This is where, at least where I have my logs configured. If I look here, I get all of the interactions, right? Nice, good things to have. But then I open this. You'll see I also get screenshots. So this is very powerful, right? This allows me to run my tests on that Linux system against Chrome, or actually I believe this also works in Edge, where I can have it, and also Firefox. But I can have this running on that system, and I can get the screenshots, but I don't have to pay nearly the price that I do on a normal Windows system for actually having the UI up. Cool. Now, what does this mean in practical terms? Well, this means actually some really, really, really cool stuff. So for instance, I can have my tests run on various different build systems. Let's see. Here I want to default to run on Ubuntu. Cool. So I'm inheriting there. This one, I want it to run on a specific Windows system. But you see how I can kind of pick and choose. And it really doesn't matter which one I run on. And this gives me a lot of flexibility. So if we look at one of these, we have, okay, we're running, we're going to be running task. We're enabling our code coverage. So you don't care about most of that, but we allow you to do So with the test runner, you can do filtering. So now we can say we want to do this type of filtering. I only want to run these tests on this system. And underneath the hood, it's actually really simple. Essentially, all it's doing is it is running a command line interface, and this is the same command line interface that you can run on the machines themselves. So, for instance, if we go back here, we can do. So we can do .NET Build, .NET Test, but what you'll see here is that just kicked off all of my tests. And that's the same thing that's happening on the build servers. And remember, we caused the test to fail, so we have that. So we can have this integrated into our build server. So this is just part of our CI/CD pipeline. And kind of a more built-out version of that can be found here, where you have your artifact, you have your web app, whatever's being deployed, and then we can run our tests as part of the deployment. So let's look at this one specifically. You'll see in this case we're using Cloud Foundry, but this can be AWS, Azure, IBM, Oracle, kind of whatever suits your needs. It can even be on-prem, so VMware. I guess Pivotal is now VMware. So you'll see here we have all of our build, deploy, cool, interesting. But now we can also run our tests as part of our deployment. So now they become an integral part of our build and release pipeline. And another cool thing, we can actually set up the tests so they run inside containers. So we can do very low level testing. So part of our container build can run some of these tests. So then it becomes context. Are these tests that can run inside of your container, or do you want these to run outside of your container? And with that, that is using .NET everywhere. I hope this was informative. Now, time for questions. Thank you. Okay, so looks like we have a question or two. Let's see. We have a lot of tests on .NET Framework. How complex is it to migrate from Framework to Core? That is actually an interesting question. The short answer is, for the most part, you probably don't need to rewrite any code. The thing that's going to be a little tough is the CS proj. CS proj, so before .NET Core, they used, well, it's always been XML, but well, for a while it was JSON, but we'll ignore that. So the .NET Framework structure, the old structure, isn't compatible with .NET Core, but they have a new structure called SDK version. And to make this a little bit simpler, I'll show you, actually show you what this looks like. So this is the SDK version. So you'll see that SDK, Microsoft.NET.SDK, and the way that you change frameworks is right here. That's literally all you have to do in your project. So you can easily switch back and forth from .NET Core to Framework to whatever. That being said, you need to get your project into this structure. And this structure is a little bit different than the traditional framework because like it doesn't say anything about files. It assumes that all files in your file system are included. So it will use those to compile. That being said, if you're doing something special, it will tag them appropriately. For instance, we have a embedded resource that we always want copied. Another cool thing is that I assume that you're using NuGet. If you're not using NuGet, that's weird, but I assume you're using NuGet, and now all of that NuGet information is moved into your CS proj. So it's now in one spot. So yeah, the code really simple. It's that CS proj. And when I do these kind of transitions, the way that I usually do it, just to make my life easier, is I will make a new. I'll actually new up a project. So I'll do new, and then probably whatever MS test or what. Let's. Yeah, .NET new, like a MS test or NUnit version, whichever one you want as your base. And then that will give you the basic structure. And then you just copy your code, structured all into that folder. And that gets you about 95% of the way there. Then there'll be some tweaking, right, based off of what are my dependencies and if there are any files that I'm doing something special with. That being said, there are pieces of functionality that are not compatible with .NET Core yet. It's becoming less and less every day, but just know that there might be some limitations, or you might have to switch dependencies for a thing or two here and there. But if you're doing like standard Selenium, you're using some of this, most of the standard packages that you might be using, like as your base, so Selenium, Web Services, Appium, all that, they are core. They have core compatible packages. They're actually the same packages, and then it determines which piece you want based off of what target framework you're using. So all those NuGet packages, if you look inside, they'll say, okay, here's the .NET 3.1 version, 3.5, Core 3.1. So hopefully that answers the question. Hopefully this was informative. It was fun to do. With that, I think we're good.